Hi, everyone. I am Eftychia Kolasi, and I work as a machine learning engineer at GWI. And today I will talk about how AI agents can reshape market research. So not as a futuristic demo, but as practical systems that help us move faster while protecting quality and trust. Today I will focus on two examples on which we've been working the last few months in my team. The first one is forecasting numbers, which we call quotas forecasting. And the second one is segmentation integration of audiences. But first, I will do a quick introduction to GWI, then cover some challenges that we face in market research, and I will close with what these examples tell us about agents as always-on systems. So GWI is where human data drives decisions. We work with large-scale human data across global markets, annual interviews, repeated waves, and long-term trending insights. That scale is powerful, but it also creates complexity. So the challenge is not just collecting data, but it is keeping it consistent, comparable, and trustworthy across markets over time. I see that there's an issue with the slides. All right, so this is our ecosystem. It connects data source, the platform, integrations, and AI products. So one of our AI products is Agent Spark, which is a customer-facing AI insights layer. But today we'll focus more on the agentic systems behind the scenes, and basically the workflows that help us make data operations faster and more scalable. And let's start with the challenges that we face in market research. So the first one is the noise. So we're entering a world where not data are all human data. We have AI-generated responses, we have bots, synthetic content, and all of those blur the line between real signal and noise. So the challenge today is no longer just collecting data, but trusting it. Next up, we have speed versus depth. So stakeholders want answers faster than ever, but speed often comes at cost of depth and rigor. So the tension is, how do we deliver insights faster without oversimplifying reality? Then more people across the organization now have access to data and tools. And of course, that is awesome and powerful, but it also means insights can be misinterpreted or used without proper context. Access without understanding creates a risk. Then we move on to strategy. So everyone talks about AI, but very few organizations have a proper strategy and know how to use it. So there is a gap between POCs and experimentations with real scalable products. And lastly, people are getting tired of surveys, and response rates are declining. We are asking for more and getting less. So we have to rethink about, not just about how we collect data altogether, but how we also make this better. So you see here some words, but let me first explain what quotas forecasting is about. So this is a process where we produce annual forecasts of internet penetration percentages across demographic quotas. So those demographic can be gender, age, education level for each GWI country. These forecasted numbers are then used to define GWI universes, which are representative internet populations per data set. So here forecasting is not just about predicting a value, it affects how we represent people in research. So internet penetration, universe estimates, quotas, outliers, all influence field work and final data quality. And that means that small errors early in the process can create bigger issues later on. Let's now deep dive into the flow, which is pretty basic actually. We have the new universe, which defines the population truth. Quotas turn that into fieldwork targets, and fieldwork collects the responses. Then weighting corrects what remains. So the important point here is that each step depends on the previous one. So if we were to have an AI system here, it shouldn't just be statistically accurate, it also should respect the research methodology. And back again to challenges. In quotas, we have a number of challenges, such as multiple data sources, previous decisions, outliers, and hard business rules. So a model, of course, can generate a forecast, but this is only just part of the job. If we add an agent there, it needs to remember context, detect problems, apply rules, and explain what changed. So this is what would make it an agentic workflow rather than just a simple automation. So before getting into that solution, I want to go back and explain what problem we were facing in quotas forecasting. So ML forecasting would generate a projection. So we wouldn't just push that projection and say that it's correct and this is what we should use. So we had researchers that have business knowledge, and they would adjust those ML projections according to that knowledge. So they would have simple spreadsheets where we would be having the ML projection, so then they would adjust those numbers and then put the reasoning behind this adjustment. And that was repeated work. The same type of review would happen every year, but it was not something that we could solve with simple programmatic rules. So researchers had extra context that was not only visible in the data itself. It was knowledge of a market, it was awareness of resource source limitations, it was historical decisions, and judgment about what looked realistic. So that is why we moved towards an agentic approach. Instead of just losing that feedback after annual review, we would use researchers' previous adjustments and comments as context for the agent. So it can make better corrections and explain them more consistently. So the agent checks, finds outliers, and corrects them where needed and uses context to make decisions more reliable. So the goal here is not magic. The goal is to create repeatable, auditable correction. Let's see now the agentic flow. So this slide shows the loop. The agent receives the configuration, then manages context and calls the model. Then executes functions, validates the result, and produces adjusted data with audit logs. So this last part is key. In research, if a system changes data, we need to know what changed, why it changed, and whether it can be reviewed. So what was the impact of this correction agent? So the impact is faster and consistent quotas. So this means we don't have anymore these ad hoc spreadsheet workflows. We have less manual firefighting and better comparability across markets. But most importantly, it creates a clearer path to scale. So expert judgment becomes part of a repeatable workflow instead of living only in one-off processes. So this slide shows a workflow in practice. This was created with Streamlit just for demos purposes some time ago. This is now how it looks like right now. The user configures the run, then the agent applies adjustments, and the output shows comparisons and logs. So the important part is that a human can review the result. So this is actually the balance that we wanted. Automation that speeds up the work but still leaves a clear review trail. And now, finally, we get to the second example, which is audience segmentation integration. Just a disclaimer here for those of you that are familiar with data science. This is not clustering. Segmentation, this is something that we do after a clustering has run. So clients often define segments in a smaller custom or a contact survey, but they want to use those segments on a much larger data set. And you would ask why not just do the segmentation on the larger data set. So the answer is money. It costs more. So they would do that segmentation on this smaller data set. We would get this data and use that as a training data set. And then run a traditional classification model and get the results back. So after the ML model has run, a rebalancer is triggered. I will get back to what this is. And if everything looks good, we integrate the segments. So this is the segmentation integration pipeline. The recontact survey provides golden questions that define those segments. Then the ML classifier learns from those answers and predict segment membership for the wider core sample. Then the rebalancer adjusts the output so that the final projected segments are more usable and realistic. And what happens in the background with the rebalancer? So when the initial segmentation, the clustering had run some time ago, we had those segments that had specific proportions. So, for example, segment 1 had 20% of the people of the data set, and segment 3 had 50%, and so on. And clients expect that those proportions are respected in what we deliver. So most of the times that wouldn't be true. So we would need to readjust our results. And that would be done by reassigning respondents from one segment to the other using their probabilities. Too much technical words, so we'll get back to the slide. So basically, we predict with a classifier, and then the rebalancer is triggered, and which makes the output fit for purpose. Why did we actually need to use AI in that product? So we had some issues, some problems lately, some client challenges. Most of those actually were solved using traditional data science or just programming. So some of those was that some segments were underrepresented, so we went ahead and used rebalancer on those. Then another problem was that some clients were requesting multiple, that respondents belong to multiple segments. So of course we used another type of classification. And then lastly, there were cases where respondents couldn't belong to some segments, which means that if a respondent belongs to segment 1, they could not, for specific reasons, belong to segment 4 or 5. So these were pretty easy to solve. Then there was a particular challenge which we could not solve really easy with just programming. And this was that a demographic group may not appear as expected in our results. And what this means is that if in the training set, in segment 2, we had 20% of women of age 35 to 44, clients would expect that a similar percentage would be also in our results. But this is pretty difficult to accomplish. And imagine that we have a lot of demographics there, so we couldn't just cover all of those cases. So this was a good place to use an agent. So the system needs both prediction and governance. So the key point here is that models optimize scores, but research products need believable population. It is not enough just to get the right number of people within a segment. We also need to have the right type of people based on the survey definition and demographic expectations. That is why we add constraint layers on top of model predictions. Finally, we got to the type of agents that, of which the one we are using right now and the other one is the next level. So right now, we have implemented ambient agents, which run in the background, are triggered by data or schedules, and they act autonomously, and humans can review the output. Next up, we want to have active agents that are next level. So it is conversational systems that help researchers ask why something happened or explore a segment in more detail. So the goal here is collaboration and not replacement. And finally, the long-term vision is to have adaptive systems. So agents could monitor their own performance, learn from human overrides, detect drift, and suggest improvements to rules or models. But in research, self-improving cannot mean uncontrolled. It still has to be governed, be measurable, and auditable. And what did we get from working with agents those last few months? So we understand that the main shift is from simple automation to reasoning systems. Agents are useful because they coordinate models, tools, data rules, and context, but the core constraints remain the same. It is about quality, speed, and trust. That is why market research is such a good place to test agentic systems. And my personal key takeaway is that we don't have to go full-on agentic systems. We can use the products that we have and just solve their limitations by integrating agents there. So we could choose a hybrid approach like we did, where we still have ML pipelines running, but we also have agents that help us automate some things. And after all that architecture, forecasting, segmentation, agents, validation, and audit logs, we arrive at the real breakthrough that no spreadsheet survived this transformation. So, except, of course, for the 12 spreadsheets that are still running somewhere in the background. So this is dedicated to every cell and every VLOOKUP that made us possible. Thank you.